Welcome back to Calculus for Econ. Today is Thursday, April 2nd, and we're going to do a real short little example on using effective interest rates to compare different investments. But before we jump into that, I wanted to just reiterate to everyone that how important it is to stay engaged with the class and all your classes, in fact, and keep keep plugging away. It's if you have any issues or questions, I'm always available by email, and if we need to, I can we can do a Zoom conference or something like that. Um, but this I know this is challenging for everyone, and so just keep me in the loop. Stay in touch. If something happens and you can't get an assignment done, let me know, and I'll be glad to extend it. And make sure that you keep checking your Hampden-Sydney emails for notifications about these video tutorials and so on. So, so yeah, with that, let's jump right in. So we had talked in our last video about the idea of an effective interest rate. And I want to put that idea to work in a little problem here. Um, Suppose that you have two investments. I'm calling them investment A and investment B here. Investment A offers a 5.02 annual rate of interest, and it's compounded quarterly. On the other hand, investment B offers a slightly lower rate of return, interest rate, 5%, but it's compounded monthly. So, which is better? So actually, effective interest rates are a great tool for solving problems like this because they sort of put everything on the same scale. And so that's going to be the key idea is to compare the effective rates for each investment. And just to remind you, the effective interest rate for an investment that's compounded, right, that has compound interest, is the equivalent simple interest rate that would return the same amount after a year. So if you convert things to an effective rate, you can do a one-to-one comparison between investments that may seem very different, and that's precisely the situation we have here. Let's take a look at those effective rates. For investment A, it was an interest rate of 5.02%. So I've just converted that to a decimal here, 0.0502. And the compounding was quarterly. So there's 4 compounding periods per year. So M is 4. And now I'm just plugging that into the formula for the effective interest rate. And so you get an effective rate for investment A of about 5.115%. For investment B, the rate of return was 5%, but it was compounded monthly, so my M was 12. And so you plug those values in, and you get actually 5.116%. So investment B is better, even though its nominal rate of 5% is less than the nominal rate of 5.02% for investment A. And so, why would investment B be better? Because it's compounded more often. And compounding is the key that really makes compound interest work. You sometimes hear the phrase the magic of compounding, and that's what's happening here. So that's a nice little application of the idea of effective interest rates. And you'll have a homework due Friday night that takes you through several problems just like that. So I hope you found this video helpful for those purposes. I hope you're well. And again, stay in touch. Let me know what's going on if you experience problems, doing assignments or so on. And above everything else, stay healthy. Y'all take care, and I'll be back in touch soon.